All right. So this is going to be the part 2 about gravity. Now, we already know that gravity is an acceleration. So, anytime you see a formula that says A equals, or in our last case, like distance equals 1/2 a t squared, right? What you've got to know is that acceleration, if you're given a gravity question, is gravity, okay? So you could see this either way in a question. They could say the gravity causes blah, blah, blah on the moon, or gravity causes blah, blah, blah on Earth, right? You're going to need to know that we can interchange gravity and acceleration as long as the question allows us to. What's that? Oh, that's scary. I thought it was a ghost. There might be a ghost in here. Okay. So, now that we've got that discussed, we've got acceleration and gravity can be interchangeable depending on the word problem. If we're talking about the free fall or dropping an object due to the Earth's gravity, every second that goes by, the object is gaining an additional 10 meters per second, or an additional velocity of 10, okay? Now, when we look at an acceleration unit, you'll notice that we have this weird seconds squared here. Took me a long time to understand why this is, and I in college, I wrote the answers with the seconds squared, or the minutes squared, or the hours squared, but I never really understood what it meant. So here's my best explanation. After 1 second that goes by from an object that falls, so the object has been falling for 1 second, the object has reached a velocity of 10 meters per second, right? So after 2 seconds, the object has then reached a velocity of 20 meters per second. So all this means, the 10 meters per second squared, is that after 1 second goes by, for every 1 second that goes by, the object gains a velocity of 10 meters per second. So after 2 seconds go by, the object gains another 10 meters per second. So the explanation is that every second that goes by, the object is gaining an additional 10 meters per second. So every second that goes by, the object is gaining an additional 10 meters per second. So I've said seconds twice, and that's because every second that goes by, it's going faster and faster and faster at this exact change, okay? So, when we talk about gravity, we're going to use 10 meters per second squared. It's really 9.81 meters per second squared. That is the gravity due to Earth, or caused by Earth, okay? So that's the gravity caused by Earth, all right? So, again, if we're given an acceleration question or a gravity question, we can always use acceleration formulas. So, Alfred and Charlie decided to have a race. Alfred is a faster bicyclist than Charlie, so he allowed Charlie to start the race before the starting line, so that when he reaches the starting line, he will be at his top speed. Okay, so just to give you some information, Charlie is allowed to start before the race. So Charlie is going to get his bike moving to his top speed, and then he's going to reach the starting line. Okay? At the starting line, he's going to continue moving at that same speed, which is 18 feet per second. Now, Alfred is there, and Alfred is going to be accelerating on his bike at 3 feet per second squared. Okay? So he's going to be accelerating at 3 feet per second squared. What Alfred wants to know is how much time it's going to take for him, or for Alfred, to reach the same velocity as Charlie. Okay? So, the final velocity that Alfred needs to reach is going to be 18 feet per second. 18 feet per second. His initial velocity is nothing, 0 meters per second, because Alfred is starting from not moving. And the moment that Charlie reaches the starting line, which is where Alfred's waiting, then Alfred goes, okay? So Alfred's acceleration is going to be 3 feet per second squared, what is the time? So what we do is we look at our different formulas. Which of our formulas has velocity changing and acceleration and time? That is going to be our acceleration equals change in velocity divided by time. So we have an acceleration and we have our two velocities. What we don't have is a time. So we need to do our algebra, multiply by time on both sides, and then that will cancel the time on the right side. T multiplied by A equals change in velocity. We need to get T to be alone, so we'll divide by A, and that'll cancel A over here. So then T equals change in velocity divided by acceleration. That is the formula that we will be using there. So let's plug it in. Change in velocity, in this case, is going to be 18 minus 0 meters per second. So we'll just do 18 meters per second divided by the acceleration, which is not meters, feet per second. My mistake. So used to saying meters. Feet per second. This is going to be 3 feet per second squared. 18 divided by 3 is going to be 6. And we're asked for a time. So we're asked for a time. And if you look here, this is kind of cool. The feet cancels the feet. The seconds cancels the squared of the seconds. And we're left with just seconds. So Alfred will reach the same velocity as Charlie after 6 seconds. Okay? So that's going to be 6 seconds is our time. All right? So that's pretty cool. Okay? If we want to find the distance that they traveled, we could use the distance formula, but we don't need to do that. We've done that. I think we've done that enough. Okay? So determining the velocity based on acceleration is the easy part. If you accelerate from 10 meters per second squared for 3 seconds, you will be traveling at a velocity of 30 meters per second. But determining the total distance based on the acceleration is very difficult. That's what we were doing before. But we have a formula for this. If you accelerate at 10 meters per second squared for 3 seconds, you will have traveled 45 meters. All right? So that is where we get into the d equals 1/2 AT squared. And the idea here is that every second that goes by, we're gaining an additional 10 meters per second squared, or 10 meters per second when we fall, right? So when we fall due to gravity. But what you need to remember is that we have this 1/2 here. So this 1/2, what this 1/2 is saying is that whatever the number we get for the AT squared, we need to take half of it to find the distance, okay? So whatever the numbers are for the acceleration or for gravity and the amount of the time that goes by, we need to half of that. So in this case, we have our acceleration and we have our time and we have the 1/2. So let's do this. A multiplied by t squared. So in this case, acceleration or gravity, 10 meters per second squared multiplied by 3 squared, or 3 seconds squared. 3 squared is going to be 9, right? 9 seconds. And then we need to multiply it by 10, right? So 10 multiplied by 9 equals 90, right? But don't forget about taking the 1/2 of this, because we need to take half of it, right? So this is going to be now 45 meters, which is what we have right here, 45 meters, okay? So the point is, when something falls, it's going to be moving faster and faster and faster and faster. But just because an object is traveling at 10 meters per second, or a velocity of 10 meters per second, does not mean the object has traveled 10 meters, because it started at a slower speed and has gained speed. So I think you're catching on to the fact that the concept behind this is very difficult. But let me break it down one final time. an object falls. Okay, so this is a building. It's a red ball. No time has gone by when you're holding it, and no velocity has happened. But then you let it go. After 1 second, so let me get the. So after 1 second, the object is traveling at a velocity of 10 meters per second, right? So the average speed between 0 seconds and 1 second, it started at 0, and at the end of 1 second, it's going 10 meters per second. So that means its average speed is 5 meters per second. All right? So the average speed is 5 meters per second. So that means in the beginning, the object then travels 5 meters, right? Now after that, between second 1 and second 2, the speed changes from 10 meters per second to 20 meters per second. So what's the average speed of 10 meters per second and 20 meters per second? That's going to be 15 meters per second, right? So the average between 10 meters per second and 20 meters per second in the middle is 15. So that means between second 1 and second 2, the object goes 15 meters. But don't forget that the object has been falling for a total of 2 seconds, right? So that means the object is now going to be having traveled 20 meters, all right? So after 30 meters per second, the object has then traveled from 20 meters per second. So after second 2 to second 3, the object has now gone from 20 meters per second to 30 meters per second, which is an average velocity of 25 meters per second. So the object travels 25 meters. Now the total distance is going to be 5 plus 15 plus 25, which equals 45 meters. So I hope you understand where the 1/2, why the 1/2 in the AT squared formula is so important. And it's because we are taking the average velocity between each second. We are not going to be using the velocity as our distance. We have to use the average velocity to find our distance. The average velocity between 0 and 10 is 5. The average velocity between 10 and 20 is 15. The average velocity between 20 and 30 is 25. And that's what gives us our distance. Okay? So you've seen now how 45 meters can be shown to you visually and shown to you mathematically. And that should give you a good basic understanding of gravity. Okay? All right, so there's the 1/2 gt squared. And remember that acceleration is the same thing as gravity. So that's what the g in there is. The g is going to be our acceleration due to gravity. So acceleration and gravity are the same thing. Thank you.